Okay guys, so this is kind of what's called a flipped classroom where I'm going to give you a mini lesson on factoring. However, notice that the key part of this worksheet, the very top, this is not anything new. You did learn this back in Algebra 1, so this is really just a review. So the county is not really implementing much time in class to do this review. So instead, we decided to take it to the next level and do it outside of class. So factoring, again, remember, is when you want to rewrite an expression or just a number as a product of two primes. So basically, you're trying to make a multiplication problem. So for instance, factors of 6 are 2 and 3. Okay, you could also say 1 and 6. You're just coming up with any multipliers to make that number. Now in algebra, we're doing the same thing. So for instance, this is a trinomial. Remember, they call these polynomials. This is a trinomial. And it's in standard form, which is ax squared plus bx plus c. We're breaking this up into a multiplication. So if you were to FOIL this, or box method, as you remember, multiply, 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 then it would make this. So we're going to go into the different types again. I'm sorry, I did take this from a teacher, so obviously many thanks to Mrs. Cooper. So I borrowed this from a friend of mine, so that kind of thing. So, but I didn't do all of it. So really, our goal now, guys, is to go through the basic types of factoring because you're going to be using these in class. So it's really important that you get these down and then use these in class. After these note sheet, okay, this is part 1 of the homework, then part 2 is going to be practice. So I have some problems, as you can see, attached that I want you to practice after using these as your model. Okay, so let's do the first type of factoring. Factoring out GCF. Make sure you would circle that. You're going to hear that a lot. Most people can remember GCF, greatest common factor, but then if I ask, what is that in plain English, they kind of forget. So remember, GCF is a common monomial, or one term, okay, so it could be letter, number, or both, all together, and basically the two terms have in common. So it's reverse distribution property. So let's take a look here. For instance, if we have 6x squared plus 12x, you could see here the GCF, the highest number that goes into 6 and 12 is 6, but when they both have the same letter, you always take the letter with the lowest exponent. So in common, they both have 6x to the first power. Now, when you factor it out, that means you're really reversing distributive property. With distributive property, you're multiplying, so here we're going to divide. So we're going to always put your GCF out in front, and then in parentheses goes what is after you divide these two terms by 6x. So 6x squared divided by 6x, or GCF, is 1x, and 12x divided by 6x is 2. And that is known as factored form. Factoring with GCF, that is factored form. That's your final answer. So again, and notice it's a multiplication problem. That's what you want to try to do. So let's try this one. GCF here, well, it's an x and a y, so there's not going to be any letter. The highest number that goes into both of them, I believe, is 6. So that's our GCF. And again, there's no letter because there's no common letter. Factoring here, we're going to take the 6 out, and it's going to be 2x plus 7y. And you're done. So you've made the product of two expressions. That's factoring. And here, highest number that goes into 4 and 24 is 4. But notice they both have the variable x raised to different powers. You always want to take the most that they have in common, which is essentially the smallest number. So we're going to factor 4x to the third. So when we take that out, okay, again, it goes on the outside. And then in parentheses is basically, remember, you're reversing distribution property. So dividing this first term by 4x to the third, it leaves you with 1x. Dividing this by 4x to the third, it leaves you just 6. And there's factored form with just GCF. Okay? So again, just a quick refresher of that. You'll get a chance to practice it. Type 2 factoring. Sums and difference of perfect squares and cubes. Now we're really, in this class, going to focus, you can cross off the cubes. We're going to focus on the squares for now, and we'll come back to the cubes later when they're more vital. Okay, so here is the rule. If you have a highlighter or circle it, Difference of squares. Okay, perfect squares. 1, 4, 9, 16, 25. All of those are perfect squares. Difference means the subtraction. So it's basically a shortcut, is that if you can do the square root of the first term and the square root of the second term, and there's a difference between them, it will always work out that you will have their square roots, okay, in an expression together. One's a plus and one's a minus. So it's kind of strange until you see it, so let's take a look. Here, I notice it's two terms and there is no GCF. You always want to start with that first, but there's not here. So I notice it's subtraction, and I know 16 is a perfect square and y to the second is. So if I do the square root of this and the square root of 16, not negative, look at it as a positive, the rule says I can do y plus 4 times y minus 4. And remember, if you go back and you FOIL this, you can actually get that answer. So we do expect you to have the FOIL or box method down. Same thing here. There's no GCF. Let's go to B. So that being the case, okay, I'm going to do it's subtraction, so it's a difference. I'm going to do the square root of that, which is 2x. I'm going to do the square root of 25, which is 5. So the rule says it's a difference of squares. So I'm going to do 2x plus 5, 2x minus 5. Now sometimes it gets a little longer. I'm going to change from marker to pen here because it's going to be a bigger. Here you can do the square root, guys, of any even positive exponent. The square root of x to the fourth is x squared. The square root of 16 is 4, so it's going to be x squared plus 4, x squared minus 4, like so. But notice you're not finished when it comes to this, guys. You still have to split up any other difference of squares. This right here is not a difference of squares, it's a sum. That's prime, meaning you cannot break that up into any other two factors. However, we have another difference of squares, so when I do the square root of both of those again, I get x plus 2 and x minus 2, meaning this entire expression, if we distribute it out, multiply it out, would make x to the fourth minus 16. This is our final answer in factored form. Okay? So you could do the same thing here. Difference of squares, so that's going to make x to the fourth plus 1. X to the fourth minus 1. Notice the sum of squares doesn't work. This won't change on the left. But here, square root, x squared plus 1, x squared minus 1. Notice how I keep splitting up any difference of squares, difference being subtraction. Again, we have another one here. So it's going to be x plus 1, x minus 1. So the final answer, you bring all these other factors down. I have x to the fourth plus 1, x squared plus 1, those are the sums, and then x plus 1, x minus 1. Okay? Even if you have different variables and numbers, that's okay, guys, for these especially. Just notice if the exponent is an even number and positive like this, we can still do the square root and do it. That would be 3x to the third, and then that would be y to the fourth. One's a plus, the other's a minus. And there's your final answer. So now, what if we take a look at problems where you might have two steps? Again, notice these are all been just two terms that we've been working with. Two terms in every problem. We'll get to three terms in just a sec, but let's talk about what if you can do two steps in once. For instance, here, I can't do a difference of squares because I don't know the square root of 27 or 3. They're not perfect squares. But watch what happens if I do my step 1, which should always be my step 1, divide out by the greatest common factor. I get that, and now I have a difference of squares. All I did was divide those by 3, and I got that. And then, yeah, square root, difference of squares, and there's my answer. I can do the same thing to the next one. Divide it by 4. That's my GCF. It always comes outside first. And then do the square root. And there's my answer. So again, you can see these are two steps where you do GCF first and then the difference of squares. So here, Let's see, if we divide it by 2, makes that 4x squared minus 25. Then we do the difference of squares because that's a perfect square. That's going to be 2x and 5. And you do 1's a plus and 1's a minus. And always bring your GCF down and put it in front. So again, you can always verify your solutions by going back and multiplying them out using FOIL or box. It's a good way to check your answer. But notice everything we've done so far was only 2 terms. So now, if you turn it to the back, we're going to look at what if it's 3 terms. We'll try to show you some of the shortcuts. So let's turn it to the back. Okay, now factoring with 3 terms is a lot of guess and check. You please make sure that you highlight or circle this. We are talking in this form trinomials, which are 3 terms that are in standard form for a quadratic. These are all called quadratics, and that's going to be our next unit coming up. So next class, this is what we're working on. What it means by a leading coefficient of 1 means that all of these numbers, and you could see in the example, there's not a number here. This is a 1, this is a 1, this is a 1. Anything in front of the x squared is called a leading coefficient. It's the highest exponent is x squared, so the number with that. You can see they're all 1. So our goal is to change each of these trinomials, these 3 terms, into a product, so a multiplication problem. So we want it to look like this for every problem. It's going to be an expression each time, okay? Now, what you need to figure out is, well, it's really a guess and check kind of game with the numbers. It'll always work if you think of 2 numbers that add to the middle and multiply to the end. So for this case, the only 2 numbers that add to 6 and multiply to 9 are 3 and 3. So, and both are positive because it's positive 6 and positive 9. So we're just going to do x plus 3 and x plus 3. And we have it factored. Okay? Here, B. What numbers, when I multiply, make negative 10? And when I add, make negative 10. And when I multiply, make 25. Only 2 numbers I can think of are negative 5 and negative 5. Now again, these examples are when they're the exact same, just to kind of make it easier. We're going to go over whether or not. Here, what 2 numbers when we add make 4 and when we multiply make 4? Okay. 2 and 2. Now again, all those examples had the same number within. Now let's look at problems when they might not. The process still doesn't change. Write them in factored form. Again, factored forms with the parentheses, so I can do that for all of these. This is our goal. And then what I do is I look at the problem and I go, okay, the first number is 1. That's my A, leading coefficient, so this will be easy type. Numbers that add to 5 and multiply to 6. Not 6 and 1. 2 and 3 are the only 2. So, x plus 2, x plus 3. It's a guess and check of the numbers, so you really have to know your integers. Here, numbers that add to negative 6 and multiply to 8. Well, when I think of numbers that multiply to 8, I think 2 and 4. And 2 and 4 will add to a positive 6, so for them to add to a negative 6, they both have to be negative. So I put them x minus 2 and x minus 4. Together, those numbers will add to negative 6 and multiply to 8. And we're done. Okay, here. Now they're not putting it here, so you make sure you verify. Add to negative 1, multiply to negative 2. Well, the only numbers that multiply to 2 are 1 times 2. So for those numbers, see, 1 and 2, to add to negative 1, the 2 has to be negative. So it has to be that. And then here, let's see. You know what? Go ahead and skip this one for now, because we're only focused on quadratics. That's okay. So those are the basic factorings. Now this is where it gets a little trickier. Okay? There's plenty of guess and check methods for this. Personally, now we're looking at when we factor when A, and again, that's that first number, and you can see here, first number is something other than 1. Okay? So you can see in these last 3 examples, it's when it's something other than 1. So, Basically, you could do a long method called factoring by grouping and split up. What we try to do here is we do what's called the T method. So draw yourself a T. What I mean here is there's no GCF, so we jump right away to the T method because the first number is something other than 1. Here's the thing, you're still going to add to the middle. So our goal is to find numbers that will add to negative 11. But it's not multiply to negative 10 because the 6 has an effect on that. So now what we're going to do is we're going to put numbers that when you multiply make 6. So I'm going to think, let's try 2 and 3. Okay, they go on the left side of the chart. Then numbers that multiply to make 10. Okay, 5 and 2. Now, here's what you do. You go across, it's kind of like a reversing of a FOIL. You go this way and you multiply. All right, 3 times 5 is 15. Put that little number over on the side. And then we do the same thing. 2 times 2 is 4. Then you ask yourself, is there any way the numbers 15 and 4 will add to the middle number? And in this case, it's negative 11. So any way that 15 and 4 will add to negative 11? Yes, as long as the 15 is negative, negative 15 plus positive 4 will make negative 11. So what we do is, since the 15 came from 3 and 5 and it has to be negative, put a minus sign there with the 5. That means the 4 is a positive, so put a plus sign here with the 2. X is always go in the left column, and you have your factors. Right, rewriting them directly across, see how I put parentheses around them? My two factors, 2x minus 5 and 3x plus 2. Okay, so it's a little trickier. This is one of the hardest ones because you really have to get down the numbers. So again, let's take a look at example B. Maybe the first time was like, what? And you might have to rewatch this. Okay, I noticed the first number, the A value, in the standard form, 3 terms, trinomial, is not 1. So I can't just go, oh, what two numbers add to 14 multiplied to negative 5? There's no numbers that'll add to this and multiply to that. So I'm going to do my T-chart. Okay, numbers that multiply to 3 go in the left side, so 1 times 3. Numbers that multiply to 5, well, it's only 1 and 5 and 1. So let's try 1 and 5. All right, here we go. 3 times 1, so remember you go like this, 3 times 1 is 3. 1 times 5 is 5. Our goal is still trying to add the numbers to 14. 3 and 5 will never add to 14. That's clear. So that means we're going to have to do more trial and error. So cross them off, and including cross these off. Don't change what's on the left yet. Usually people just change what's on the right. Now, we did 1 and 5, but the only other numbers that multiply to 5, I mean, it's still 1 and 5. So flip the order, 5 and 1. So let's try it again. 3 times 5 is 15. 1 times 1 is 1. Is there any way that 15 and 1 will add to 14? Yes, as long as the 1 is negative. So when we go back and we write our answers here, the 15 is positive, and see how it was 3 times 5 made the 15? Since it's a positive, put a plus sign. Here, the negative 1 came from the 1 and 1, so I'm going to put a minus sign. And then the x's go on the left column with those constants, or numbers I should say. And then I put the parentheses around, and I get 1x plus 5 times 3x minus 1. Okay, so that is the trickiest kind, and we're going to skip C for now. What I want you to do is try the problems on the extra sheet, okay, as the rest of the homework, and just try them. Again, this is not anything that's new. It's based on what you've already learned, but it's a skill that you're really going to need for this upcoming unit, and honestly throughout the rest of the year, and especially for those that go to college algebra or pre-calculus, you're really going to have to keep factored under your skill. So we're going to be doing it a lot. So give it a shot, and I'm going to check it in class when I see you next.